Hello everyone, this is Miss Martinez. Today we're going to talk about 6.K4.1, comparing quadratic functions, looking at them in different representations. So we've got from a graph, from a table, and from an equation. Okay, so when you are comparing means to decide what is the same and different about something, and to describe those similarities and differences. So those are the two main things that we're looking for. And so some things that you will want to include in your comparison are just going to be all of the key features that we have talked about so far with quadratics, and then any of those just characteristics that we've talked about throughout. So those include, you'll want to write these down, things like your vertex, how wide the graph is, so that comes from your A value, right? Does it stay normal? Does it get skinnier or wider? And then also A tells you the direction that it's opening. So does it open up or down? Which also tells you whether it has a minimum or a maximum. So those two key features as well. Things like the zeros. Remember, your zeros are, it's another word for your x-intercepts, or the solutions. That's another name for them. Key features like domain and range. Increasing and decreasing intervals. And your positive and negative intervals. Also, another thing that you could include when talking about whether it has a minimum or a maximum, you could also include the actual value. So that minimum or maximum value, which is K. Okay, all of these things we've talked about before, it might be helpful as we go through all of these comparisons to have your key features notes out. That's the one, it's actually the one that I gave you right before we had AMI, and it's got your domain, range, increasing, decreasing, positive, negative, all of that. That's going to be a really good reference to have as we go through some of these. These are things that you've already learned, but we're just finding all of these things from two different functions right now so that we can compare them. Okay. So let's start with the first set with function 1 and function 2. So function 1 here, we've got a graph. In function 2, this is quadratic, but from a table. Okay, it's just a table of values instead. So I would focus on looking at your list of things to compare and starting to find each of those things for each one. So let's start with function 1. Let's find that vertex. Here it is. And I know that that is 2, 1. I know that this graph is opening down, so that's going to be super helpful. It has a maximum. And we're gonna wanna know what this A value is to figure out the width of it. So remember, you look at your vertex and then the next point that has a run of 1. So that would be either at the 3 or at 1. Okay, and so to get from the vertex to that next point, we would go down 1 and then right 1. And then the next thing you do is then you go down 3. Oops. Down 3, right 1, and that follows our pattern when A is 1. You only need to look at those first 2 points though. So those first 2 points are sufficient for that. So we know that A must be -1 because it's opening down, so it's got to have a negative A value. Okay, now that we have determined the vertex and the width, we've got our zeros also. So that's where they cross the x-axis. We've got one at -1, or I'm sorry, at +1, and then at +3 there. I'm just gonna erase this part so it looks a little cleaner. Okay, let's find those same features on the table now for function 2 so that we can kind of start processing what our Venn diagram is going to look like, where we're going to start organizing things, what's the same and what's different. Okay, so remember when you do a table for quadratics, your vertex is in the middle because that's your center point. It's in the middle of everything, and then the points on either side of it are symmetrical. So here's my vertex is at 2, 3. Now I can already see right now that those are different. So I know that those are going to go in the separate bubbles here. So for function 2, my vertex is 2, 3. But for function 1, my vertex was 2, 1. So those are different. So I'm going to put those on the different sides there. Okay. I need to determine my A value. So I do this similarly to what I would do on the graph. I'm going to go from the vertex and then to those next 2 points there on either side. We're going to find that change in y here. So to get from 0 to 3, I would be adding 3 here, while my run is adding 1. And then over here, to get from 3 to 0, I actually subtract 3. While I add 1 on the x's. So we know that we have an A value of either 3 or -3. So it's been stretched, it's gotten skinnier, okay? We just need to determine which direction this graph is facing so that we know if it's +3 or -3. So what you'll want to do is look at your y values from the vertex point here, from this 3. And let's look at those other y values. Are they increasing or are they decreasing? If they're increasing, your graph would open up like this. And if they're decreasing from the vertex, so this is increasing from vertex, These are your f of x values or your y values. If they're decreasing from the vertex, then you'll be opening down here. Okay, so from 3, we go down to 0 and then down to -6 on both sides. So those are getting smaller. So we are decreasing from the vertex here. Okay, so that means that my A value must be negative. So it's going to be that -3. Okay, which is, it got skinnier, whereas the other one we had -1, which is a normal width. Okay, so their widths are different here. Yep. So because it's opening down like that, we know that it has a maximum here. And our function 1 also had a maximum value because it's also opening down. So that's something that they actually have in common. So that's our first thing that we've noticed that they have in common, is that they're both opening down. Which means they both have a maximum. Okay, the next thing was the zeros. We can also see the zeros from the table. Remember, your zeros are your x-intercepts. So that is where y, or f of x, is 0. And that's these 2 points here. 1, 0, and 3, 0. So this is an x-intercept, and this is an x-intercept. Now our x-intercepts on function 1 are also 1, 0, and 3, 0. So they share the exact same zeros. Let's include that in our shared space here. Now it's really important when you are filling out your Venn diagram that you be specific. Don't just tell me that they have the same zeros. Actually tell me what they are. So we're going to list them. 1, 0 and 3, 0. Okay. So now for our domain, range, increasing, decreasing, positive, negative, all of that. So remember, your domain for all quadratic functions is infinite, so that's something that they're all going to share, is that infinite domain. So I'm going to abbreviate that with D. Is infinite, negative infinity to positive infinity. Remember, those are your x values. Our range, though, is going to be different because our vertexes are different. So remember, your vertex gives you that very maximum point. So your range, since we're opening down, let's look at function 1 first. Remember, these continue on forever. My very, very lowest y value, if I read this graph from bottom to top, would be negative infinity. So my range is going to go from negative infinity all the way up until the top of the graph. So at the vertex there, my y value is 1. So all the way up till 1. And since that point is included, don't forget your bracket on your range. That's the only time you use your bracket on your key features. So for function 2, it's also opening down. So the very, very lowest y value will also be negative infinity. But since this graph has a vertex of 2, 3, that y value is going to go up until 3. So whatever k is always tells you that maximum or minimum y value. Which in turn, that tells us what our minimum or maximum value is, and they have different ones, so we could include that. Function 2's maximum value is 3. And function 1's maximum value was 1, so those were different. Now, when you are writing your increasing, decreasing, and positive and negative, remember that as long as you know what the zeros are, that's going to help with your intervals for positive and negative, because that shows you where the graph changes from being below the x-axis to above the x-axis. And then for increasing, decreasing, that changes at the vertex. So as long as you know what your vertex is and your zeros are, you can determine your increasing, decreasing, and positive and negative. Super easy. So for function 1, my increasing interval, that's on the left side of the parabola. So that's from negative infinity all the way until 2. Remember, you use your x values, okay? Well, function 2, the x value of its vertex is also 2. So they should have the same increasing interval. From negative infinity to 2. And that's because they share the same h, which is the x value of the vertex. Now decreasing, if they share the same increasing interval, then they would share the same decreasing interval, because it decreases right after it increases. So from 2 to positive infinity, that's the right side of the graph now. Okay, now also, since they have the exact same zeros and they're both opening in the same direction, they're both opening down, they're going to have the exact same positive and negative intervals also. So let's do positive first. Remember, positive is when the graph is above the x-axis. And if we look at function 1, it's above the x-axis from 1 to 3, from the first 0 to the second 0. It's one interval, happens one time. And it's the same for function 2 because they have those same zeros. Now our negative, just gonna draw an arrow here since we kind of ran out of room. These two have a lot in common. Our negative happens in two places. It's below the x-axis, that little bottom leg on the left, and then again on the right after it crosses the x-axis again. So for negative, that happens from negative infinity all the way to that first x-intercept, which is 1. And remember, when we have two places, we use that union symbol. And so then it goes below the x-axis after that second x-intercept from 3 and then to positive infinity. Okay, so that's how we compare those first two functions, function 1 and function 2. Those are all of the things they have in common, and then all of the features that are different. Okay? So now let's do the same thing, but for function 3 and 4 here. Now function 3 and 4, we've got a different mix. So before we had a graph and a table. Now we've got an equation and a graph. Okay. So we've got function 3 is the equation and function 4 is the graph. So same thing again, let's just go ahead. I always think it's easiest to just start with the vertex. And this is in vertex form. So when you're looking from an equation, identify what your h and k is here. Remember your vertex form is a times x minus h squared plus k. I see that there's a k, but there's no h. There's no parentheses, so there's no h, which means h is 0. So my vertex is 0, negative 2. Now let's look at the graph. My vertex is here, which is also at 0, negative 2. So that is something that they share. They have the same vertex on these two. So we can go ahead and add that. Vertex is the same, and I'm being specific by putting what it is, 0, negative 2. Okay. We know on function 3, we can also identify the a value. A is negative 1/2, which means that this will open down and get wider since a is a fraction. We might just want to make note of that a is negative 1/2, so we remember those features when we put them in the Venn diagram. But we need to determine a on the graph. So starting from your vertex, we want to calculate the rise over run to that next point over. And what it looks like happens here is that we don't even go up a full box on this one. We only go up halfway and then run 1. Okay, so that's up by a half, and then we run 1. So anything divided by 1 is just itself. So that means that a is 1/2 here. I know it's positive because the graph is opening up. Okay, so something different about them. Function 4, the graph is opening up, and then we know function 3 is opening down because a is negative. So let's add those in. Function 3 opens down. which means it has a maximum. While function 4 is opening up and has a minimum. Okay, now let's not forget about the width. We did address the direction that it opens, but if you notice, they both have a half. So they both got wider by the same amount. So they actually have the same width, just facing in a different direction. So you can include that in something that they have in common. We can say that they have a wide width, or a width of 1/2. Okay, on the graph, let's identify a couple other things while we can. I see the zeros here. We've got 2 of them, one at -2 and one at +2. But we need to determine the zeros of the equation. Because we just have the equation, we're not sure what these are. So what you can do if you're given an equation to find the zeros, and then of course to find any of the other key features. For now, I'm just gonna have you graph these in Desmos. So make a note that you can graph on Desmos. Okay, so take a second to go to desmos.com and enter this equation in and graph it. Okay, so you should have gotten something that looks like this. Just like we talked about, the graph is opening down, and it has that vertex at 0, -2 here. And notice, so we wanted to know what the zeros were, which is where it crosses the x-axis. This graph does not cross the x-axis at all. So this one does not have any zeros. So that is different than this graph. Function 4 crosses the x-axis twice. So we know that they are different when it comes to their zeros. So we can put that next. Function 3 has no zeros. While function 4 had 2 of them, and let's be specific and list them. -2, 0, and +2, 0. Okay, well, remember that domain is always the same for all quadratic functions. So let's include that as something that's the same here. It covers all those x values from -infinity to +infinity. Since these are opening in different directions, they're automatically going to have different ranges. So if we look at function 4, since we've got it here, from the very lowest y value to the very highest y value, if you read it from bottom to top, the very lowest y value on this one is -2. And that's included because it's on the vertex. And then the very biggest y value possible would be positive infinity, since it's opening up and continuing on forever up there. Now let's go to our Desmos graph and decide on the range for this one. Since this is opening down, my very lowest y value is negative infinity, and my highest y value is that maximum value of -2. So my range should go from negative infinity to -2. Okay, and then also because these are facing opposite directions, their increasing and decreasing intervals will be different. And then same thing with their positive and negatives. So let's do those for function 4 first. Increasing. Oops. Not sure what happened there. Okay, so let's look at increasing. On function 4, this would be, it's increasing on the right side. So the x values that happens at are from 0 to positive infinity. And then it decreases on the left side. So least to greatest again, so from negative infinity to 0. And then this one is positive above the x-axis in 2 different places. From negative infinity to -2. It always crosses that x-intercept, or the x-axis at the x-intercept. So that's why that's kind of your changing point there. And then again, starting at the other x-intercept from 2 to positive infinity. And then lastly, negative. This is when our graph is below the x-axis. So there's only one piece of the graph that happens at, and that is from -2 to 2. Okay, oops, I just noticed that there is not a bracket on that range there. Okay, let's go look at this graph here. So this one is increasing on the left side. So this left piece of the graph, so from least to greatest, that's negative infinity to 0. And then it'll be decreasing on the opposite side, so on the right side, and that'll be from 0 to positive infinity for those x values. Okay, it's actually opposite of the other one, and that's because they're facing different directions. So now let's look at positive and negative. Is this graph ever positive? Does it ever lie above the x-axis? And I don't see that it does. The entire parabola is below the x-axis in the negative region. So this one actually doesn't have any interval that's positive. It's all negative for every single x value. So from negative infinity to positive infinity, the whole graph is negative. So that's my negative interval. Negative infinity to positive infinity. And then if you want to make a note that it's never positive, you can do that. You wouldn't have to, it would just be implied. But let's just add it for good measure. Okay, so we've done it. We've compared two different sets of quadratic functions represented in different ways.